Okay, so in this class I'm going to talk about finding the circumcenter of a triangle. In this class, of course, we looked before at finding the different kind of important folds of a triangle, and in my last class I found the centroid, a different type of center. In this class we're looking at the circumcenter of a triangle, and the circumcenter of a triangle is the point where the three perpendicular bisectors of the sides of the triangle intersect. So in order to find the circumcenter of a triangle, you have to be able to find, to construct the perpendicular bisector of the side. That's a junior cert construction, and we've gone over it in a few classes, so make sure you're familiar with that fold of a triangle. Really important quantity, or characteristic I should say, of the circumcenter is that it is equidistant from each vertex, and therefore is the center of the circle. A circle containing every vertex on the triangle. So let me have a quick look at an example here. Here I have a triangle marked in the usual way, ABC. I've got coordinates. To find the circumcenter, I want to find the perpendicular bisector of each side of the triangle. So in order to find the perpendicular bisector of each side, I need to be able to find the midpoint. So I'm going to go up here to my point menu and choose the midpoint, and I'm going to choose the midpoint of this side, which I can find. And once I have the midpoint, I can draw a line perpendicular to that side through the midpoint. So I'm going to go here to my perpendicular line menu. I click on the point that I want the line passing through, click on the side I want the line perpendicular to, and GeoGebra draws that line in there. GeoGebra has called that line F. F here is the perpendicular bisector of the side with endpoints at A and B. Okay, actually side is little c, probably a better way to call it. Opposite vertex big C. And if I want to draw the perpendicular bisector of side little a, well, again, I just have to first find the midpoint, and I do by in GeoGebra by clicking on my point menu, midpoint or center. Click on your line segment. There's my midpoint, and then my perpendicular line menu. I'm going to draw a line perpendicular to this side through E. So through E, perpendicular to the side. I just click on the point, click on the side, and there's my perpendicular bisector. And then finally, I'm going to draw a perpendicular bisector of the third side. Actually, to find the circumcenter, I've already found it. Let me actually mark it in. My circumcenter is going to be that point in there. The point F. I'm just going to put that in a different color here, just so we can really see it clearly. I'm going to just change its color to red. Maybe make it a little bit bigger, just so we can see clearly. So that point in there in the middle, big F, that's the point, that's the circumcenter. Okay, that's the circumcenter of the triangle. Now I'm going to draw the perpendicular bisector of the last side. I don't need to, I've already found the circumcenter. But I'm going to draw the perpendicular bisector of the last side, just because I want you to see that it will go through F as well. So, midpoint, go to my point menu, midpoint of the side B. I just click on the side B, and then my perpendicular line menu, perpendicular line through the point G, click on that, perpendicular to the side little b, click on side little b, and there it is. And you can see it passes through there. Now this triangle is an acute triangle, meaning all angles in this triangle are acute. If I open this up to be an obtuse triangle, where I have an obtuse angle in it, so let me move this point around. What happens in an obtuse triangle is that the circumcenter is not contained within the triangle. It's actually outside the triangle. And if I draw a right triangle, the circumcenter is exactly halfway along the hypotenuse. So have a think about why that is. The other thing, and the really important characteristic, is that the circumcenter is equidistant from each vertex. You've got to remember that. And therefore is the center of something called the circumcircle. And the circumcircle is just a circle that passes through all three vertices of the triangle. I can draw the circumcircle by going to my circle menu. I'm going to choose F, my circumcenter, to be the center. And if I draw a circle through any of these vertices, it'll pass through the other two. And again, let me move around some of these points here. You know, if I look at say a right triangle, notice the center here exactly halfway along the radius. Remember, that's a theorem actually from your junior cert. From your junior cert said if you take a diameter of a circle and draw two legs that meet at the circumference of the circle, they will meet at a right angle. That's related to circumcircles. An acute triangle, just move this point here. An acute triangle, the circumcenter is inside, and again the key detail, circumcenter equidistant from the vertices of the triangle, so we can draw a circle. So acute triangle, circumcenter inside, right triangle, circumcenter on the hypotenuse exactly halfway along, obtuse triangle, circumcenter outside, but the circumcenter is always equidistant from the three vertices of a triangle, and that distance is just the radius of whatever the circumcircle is. Okay, so that's how I'm going to find it on GeoGebra. Let me look at how I would find that circumcenter. Let me go back to my original triangle that I had. 1, 2, 4, 5, 1. So there's, I think, the original triangle I had. You can see that point there is actually 3, 2. I want to see if I can find this without GeoGebra. So I want to find the circumcenter of the triangle without using GeoGebra. So step 1, I'm going to find the midpoint of two sides. To find the midpoint, we use our midpoint formula. Remember, we said the midpoint of any side is always equal to the average x comma the average y of the two endpoints of that side. So the midpoint of the line, the side with endpoints at A and B, well, the midpoint is going to be the point, the average of 1 and 5, which is 3, comma the average of 1 and 1, which is 1. So the midpoint of that side, little c, is 3, 1. If I take the side little a, midpoint is around here. The side little a, I want to take the midpoint of that side. Well, it's the average x, the average between 2 and 5, and that's going to be 3.5. Add them together, divide by 2. And the average of 4 and 1. Add those together, 4 and 1, 5, 2.5. That's my midpoint there. And now what I want to do is draw lines perpendicular to these sides, passing through these points. So this one's easy because this side is horizontal. The line perpendicular to it will be vertical. So I'm going to draw a vertical line through the midpoint there. And the equation of that line, let's call that line L1. The equation of L1, where L1 is the perpendicular bisector of side little c. The equation of L1, well, it's a vertical line, so its equation is going to be x equals, well, the x coordinate is going to be 3. And again, if you're unsure about that, make sure you've covered the lessons on the equations of vertical and horizontal lines. The second line I'm going to figure out is this line passing through A but perpendicular to the side B. See, this is not exact. I haven't done this precisely. I don't know that it's exactly 3.5, 2.5. It's a bit of an approximation because I don't have grid lines. Remember, from junior cert there is a construction to construct the perpendicular bisector, so that's something maybe you might look up. But again, I'm just going to cheat here a little bit. In fact, no, let me go through. I will go through the construction. Let's go through the construction. So to construct the perpendicular bisector, I would use my compass. What do? I place the needle at this end point, place the pencil beyond halfway, sweep an arc. I'll make this arc very faint. Sweep an arc around like so. Do the same from the other end point. Keeping the compass the same width. So from the other end point, there we are. And draw an arc like so. And then drawing a line through where these points meet, drawing a line through those from there to there. So that's going to be my perpendicular bisector of that side. Okay, so that's my perpendicular bisector of that side. I want to look at the equation of this line here. Let me extend it a little bit and extend this line a little bit out this direction and down this direction. And where I extend it a little bit, you know, I'm going to find the equation of this line. This line is the perpendicular bisector of side little a. It's going to have equation line L2, and I want to figure out what that is. Okay, how do I figure out what it is? Well, I have to find its slope, and I have to find a point. We do know the point. We know a point 3.5, 2.5, so I can use point slope form. Y minus 2.5 equals m. I need to find the slope times x subtract 3.5. So to find the slope, how do I find the slope? Well, the key detail here is it's perpendicular to the other side. So if I can find the slope of side little a, I'm a business. So I'm going to find the slope of side little a here, which is endpoints at B and C. It's the rise over the run. The rise is the change in y. 4 to 1 is a change of -3. The run is the change in x. 2 to 5, well, that's a run of +3. So that has a slope of -1. That means the slope of my line that I'm looking for, line 2 here, is going to have a slope of, well, what's the reciprocal of -1? The negative reciprocal of -1 is +1. So this slope in here, m, is going to equal to +1. So I'm going to put in a +1 in there. Let's get rid of that. So the equation of line 2 is going to be that. Let me just write that maybe in a simpler form. So maybe I'll double both sides to get rid of these decimals. I don't really like those. So I'm going to get 2y subtract 5 equals 2x subtract 7. Okay, so 2y subtract 5 equals 2x subtract 7. That's my equation. I can write that in standard form if I want. That would be the equation 2x subtract 2y subtract 2 equals 0. Okay, and dividing everything across by 2, that's just going to give me x minus y minus 1 equals 0. That's the equation of the line L2. Okay? So where is the circumcentre? Well, the circumcentre is going to be the point of intersection of these two lines in here. How do we find the point of intersection of two lines? This line and this line. Well, we find the point of intersection of two lines by finding values of x and y that satisfy the equation of both lines simultaneously. So line 1 is really nice because it's just x equals 3. So x equals 3. We're going to plug that into line 2, which will give me 3 subtract y subtract 1 equals 0. And from that, I can see that y has to equal to, add y on both sides, I get y has to equal to 2. So I have an x coordinate of 3, a y coordinate of 2. That is my circumcenter, 3, 2. Once I draw that circumcenter, I can, if I want, take my compass and I can draw the circumcircle. Okay. Remember, the key detail about the circumcenter is it is equidistant from all endpoints of the triangle. So make sure it's the right width here, and then just sweep a big circle around, and it should go through all 3 vertices. Okay, so that's the circumcenter, 3, 2. There it is, really easy to find it on GeoGebra, 3, 2. A little bit more complicated to work it by hand, but very doable. What do I have to know? Well, I have to be able to find the point of intersection of 2 lines. That's the last part I did. I have to be able to find the equation of a line, which means finding a slope and a point on the line. We find the point on the line by finding the midpoint. Vertical lines always are of the form x equals something. Diagonal line, I use the point slope form of the equation of a line. I have to work out the slope of that second line. I do it by knowing the perpendicular bisector is perpendicular to the line, and then I can find the slope in that way. Okay, so practice questions on finding the circumcenter. You gotta know it.